Greetings, mathletes, and welcome to our next exciting algebraic adventure. Today's adventure is going to be the rectangular coordinate system and graphing lines. It's good stuff. So let's go ahead and get started here. So what everything is about today is finding solutions to a particular type of equation. Those solutions actually end up being graphed on a on a graph. We'll talk about the grid here in a minute. And it turns out that these types of equations have more than one solution. So as a matter of fact, they have an infinite number of solutions. Now, that doesn't mean anything will work, but there are an infinite number of them. So let's go ahead and take a look at this particular type of equation. This is a linear equation. And let's see here. Here's the equation that we're going to be messing around with, right? So here's the thing. There's probably some things you'll notice about this right off the bat. One of which is that there are two variables here, right? So every solution has two parts to it. It has what x needs to be and what y needs to be to go with it, right? So you have two variables. Once you pick one, the other one is determined. And we'll talk about how to get those things. Here's how we represent these things. So because there are two variables, let's look at this. This actually happens to be a solution. X is equal to 10 and y is equal to 2, right? Now, we represent those solutions in a slightly different way. We don't write out the x and y each time. Instead, what we do is we write it down in what's called an ordered pair. So the x is going to be the first number you see, and the y is the second number. Although you almost never see the x and the y, what you see are the numbers. You're intended to understand that the first number is an x and the second number is a y. So this right here, this particular solution, if I were to write it using an ordered pair, would be 10, 2. Right? And so that's a point. And that point can be located, and this is why I brought the grid out here. We can locate this on the grid. We know that 10, let's scoot this over a little bit so we can actually get it in there. Now we can go to 10. 10 is the x value and 2 is the y value. And so I've taken the liberty here of creating a little thing where I have vertical and horizontal lines. So x is 10. So what we do is move over here on the x-axis. The horizontal axis is the x-axis. So this one right here, let's see if I can do this. It's not going to let me put a name on it. Oh, I can do it this way. Here we go. Down here, this is your x-axis. Okay, so that's the one that goes horizontal. Notice it's just a number line is all it is. You have a 0 in the middle, and then you count all the way over here to 10, and what this line represents is all the points on this grid that have an x-coordinate of 10. Okay, now the other axis over here is called the y-axis. And the y-axis is the vertical axis. It's the ones that go straight up and down like this. And it's just another number line. Basically, you take two number lines and you cross them at the zeros. That's what ends up happening. So if I want to find a particular point, I know the x is 10, right? I got the x right there, and I've already lined that up. But then y is 2. So I have to take this one that shows me all the y values, and I lined it up here at the y is 2, and I can see that those two things cross at a point. They cross right here. And if I click that, it's going to lock those lines in. So I'm going to do this. I'm going to scoot this just a second here. So the point is actually here at 10, 2, and we can see as we move this line over, the x value is 10, the y value is 2. You can actually see how they line up, right? The y goes through 2, the x goes through 10, right? And so that's a very convenient way to do this. When you plot these in your homework or in your casual work, you wouldn't be writing these vertical and horizontal lines in. All you would have is the point located where it's supposed to be located. Okay, so that actually represents the first solution, a solution. It's not the only one by any means, but it is a solution. So I'm going to actually hide these guys for a moment, get those off of there. Now, what we have to do is be able to find some other solutions to this thing. That's one of the solutions, but this thing has an infinite number of solutions. So I'm actually at this point, first of all, I want to demonstrate that this one is a solution. We have 10, 2. You can always check this just by plugging in the values. So the x value is 10, so that means it's 2 times 10. And then here, let's see, that's -5. So -5, and then the y value is 2, is equal to 10. And remember, an equation, a solution to an equation, is the value of the variable that makes this true. And so we have to see if this actually comes out to be a true statement. So 2 times 10 is 20. -5 times 2 is -10, and that equals 10. And so that's absolutely true. So that works, right? That's a winner. Now, we can't graph it with just one point, right? We need at least a second point. Because if you look over here at this, there's actually an infinite number of lines that I can draw through this thing, right? It doesn't determine a line yet. And we want to be able to narrow it down to a single line. So let's go ahead and see if we can find a second point. Now, we're not finding them just yet. I'm going to hand it to you. So my proposal is that this is a second point. Point 50 is also a solution. So let's check that. So that means x is 5. So that means 2 times 5 minus 5 times, let's see, y is 0 equals 10. Boy, I'm running out of room real fast here. Right? 2 times 5 is 10. And then 5 times 0 is 0. 10 minus 0 is 10. And so this is also a winner. Right? So now we have two solutions. Now watch what happens when I graph the second solution. Now it's the point 50, which means, oh my goodness, I didn't want that there. Okay, so what that means is that the x value is 5 and the y value is 0. So let's look at what that actually means here. So let me... Oh, there we go. Show all hidden. There we go. I just wanted those guys back. Okay, so it says the x value is 5. So we'll put it right there. And the y value is 0. Well, the 0 on the y-axis is right here. So that actually makes it a point on the x-axis. So let me move these things out of the way so I can mark the point. And that puts it right there. So now we have a point on the x-axis. Now, here's what's interesting about this. So, and I'm going to write this down before I lose this stuff. So we've had two solutions so far. Oh, let me switch colors. We've had the point 10, 2. That's a solution. And then we have the point 50, and we've marked that. That's a solution. And so now I just want to give you guys a little heads up, and then we'll look at one more solution. So first of all, let me go ahead and hide those. Okay, so we have this solution and this solution. And surprisingly enough, that is enough to determine a line. There's only one line I can draw through those 2 points. Oops, There we go. Now, so let's look at something else here. So we have the point 10, 2, we have the point 5, 0, and it looks like from this graph, now that I have 2 points, it looks like this point is also a solution. And so we need to check that. And so I'm going to erase some of the work I have down here so we can check the last thing here. Just erase that too. There. Okay, so what it looks like, and if I'm looking at this, see the x value is 0, the y value is -2. So we're checking the point. There we go. There we go. Okay, yeah, so we're checking the point 0, -2. We want to see if that works. In fact, it's probably a good idea just to check it yourself right now. So just go ahead and pause it and see if you can eke it out. Some of you may have done it in your head already. Okay, so if we go ahead and plug this in, that gives me 2 times x, which is 0, minus 5 times y, which is -2, is equal to 10. Well, that goes to 0, and -5 times -2 is +10, is equal to +10. And so that point also works. In general, when you're asked to find a third point, it's only to verify your line. It's not because you have to have it. What you need to graph a line is 2 points, always. In fact, it used to be an old adage, 2 points determines a line. People don't seem to remember that. I think part of that's because geometry isn't taught quite as much, at least not from the proof side of things, in high schools as much anymore. So in any case, we've just found 3 solutions and we have verified that all 3 of them work. Just so we know what it looks like, I want to go ahead and try to check a point that doesn't work so we can see what it looks like when it doesn't work out. Let me write this one. We know these 3. There we go. Yeah. We know these 3 are solutions. We've checked them, we've graphed them, we have the whole business over there. Let's check to see if the point 5, 1 is a solution, just so we know what it looks like when they're not solutions. Because one of the things you're going to be asked to do is you're handed a line or an equation of a line, and you're handed a point and you're asked if the point is a solution or not. And so you have to be able to plug it in and check. Plus, it's going to turn out that checking our solutions is actually a way of finding points, kind of. So let's plug this in. Let's see here. 2 times 5 minus 5 times 1 is equal to 10. Well, let's see here. That's 10 minus 5 equals 10. And that is definitely not true, right? That's a lie. 10 minus 5 is not 10, unless 5 is a lot smaller than I thought it was. Right, so this is not a solution. And what's more is you can tell it's not a solution because if you go ahead and graph the point 5, 1, you can see that it's not on the line. In fact, I'm just going to put it in here. So let's see here. 5 goes to here and then up to 1. Did that work? No, that didn't work. Did it work? Whoa. Hey, it zoomed. Right, there's my point. Ah! How do you get out of this? Okay, so that is the question. Crap. Okay, I got it. All right. So what I really wanted to do here was mark this point. I'm just going to do this. So the point 5, 1 is right here. And you can see it's not on the line. Anything that's not a solution won't be on the line. If it is a solution, it will be on the line. And as a matter of fact, every point on this line here, every point, this point, this, oh, not that point, this point, this point, this point, this point, this point, anything you click that's on the line, anything that you mark that's on the line is a solution to the equation, whatever those numbers are. And so The line is a representation of all of the infinite number of solutions that you have. So it's kind of nice that you can just find two solutions and extrapolate that to all of the solutions. And that's what we're going to be looking at. Now, I'm probably not going to use this grid. I wanted to show you the horizontal and vertical lines just so you can kind of see how that worked. It's going to be a lot more expedient if we can just use the whiteboard here for the rest of this. So let's go ahead and open that up. Now, so we've gone through, and believe it or not, we've checked our solutions, right? We've looked at what a linear equation looks like, and we've graphed a line from some points already. That's a lot of stuff really quick. Where I want to go with this now is we're going to back up because I've given you kind of a light introduction to everything, and we're going to start looking at how to actually find the points that might be solutions. Because if you're just guessing randomly, you're going to be guessing for a long time, a very long time. And we want to have something that'll work a little bit quicker. Oops, that's not what I meant to do. One of the things that a lot of people don't realize going through school is that every method for graphing a line is the same method. They look a little bit different, but every single one of them is just about finding 2 points. So if you remember, if you've covered this stuff before, and this is a refresher for you, one of the things you remember is that you'll have the slope-intercept form, and you have a set of methods for graphing those. You might remember the standard form. It's not always covered, but the standard form is pretty common. And you have a different set of methods for graphing that. And then you have other stuff. You'll see other things, and you might have learned even other methods, but all of them boil down to this exact same thing: finding 2 points. That's all you're ever after is 2 points. You find 2 points, and you've determined your line, and you can graph it. The third point is just to double check to make sure one of your first 2 isn't wrong. Okay, now there's, excuse me. There's 2 main forms of the line that we're going to see as we go through this semester. At least these are the 2 I like to focus on. The first one is going to be very familiar to you, and it's actually 2 different formats, but we're only going to use one of them. I'm going to show you both for right now. And this is called slope-intercept form, right? The slope-intercept let's get this backwards a little bit. The slope-intercept form, let me switch colors. I don't like that color. Is the form, and you've probably seen this, y is equal to mx plus b, right? And we haven't talked about what m or b are, but we'll get to those. Those are actually in future sections. But anything that looks like this, just know that m and b are numbers, right? X and y are your variables, m and b are your numbers. Then the other form is called standard form. And standard form is kind of peculiar. It looks like this: ax plus by equals c. And there's this really weird rule, is that A, B, and C are not fractions. So later on, we'll talk about how to switch between these 2 forms. So you have the slope-intercept. Right, you have the slope-intercept, and then you have the standard form. Interestingly enough, the standard form, it has that no fraction rule. It actually, it has to do with the limitations of the old printing presses. It was very hard to make fractions with those old printing presses, and so they found a form of the line that had no fractions. And that's pretty much what everyone used up until, probably about 40, 50 years ago, it started changing. And you stop seeing this form so much, and you start seeing this form a lot more. And the reason for that is b is typically a fraction. Now, the other form that you'll see this one in, it's literally the same thing, but there's a slight difference in notation, and so that enables you to do some other things. Sometimes you see this in the form f of x is equal to mx plus b. And technically that's function notation, and we haven't talked about functions just yet. So we'll come up on that. This will definitely rear its head, though. We will definitely see the mx plus b form as we go through this in the function. Okay, so the stuff we're going to see today is going to look like this. It's going to be in one of those forms for the most part, and then there's two exceptions. There's a form that looks like x equals a, where a is just some number, and then you also have the form y equals b, which is just b is some number. And so we'll play around with those also. But that's what we're going to be hitting now. Okay, so let me go ahead and clear this off, and we will take a look at our first example. All right. Okay, so let's go ahead and switch corners here. And let's go ahead and take a look at our first example. Okay, so let's say we want a graph. Didn't I just do that? There we go. Graph y is equal to 2x plus 1. Okay, so this first method that we're going to be learning is just finding points. It's doing it in the clunkiest way possible, but it's just to make a table of values. And incidentally, despite my terrible handwriting, this is the best way to get a hold of any new equation you have to graph. Start plugging in points and see what happens. So you make yourself a table, right? Make yourself a little XY table. Sometimes they're called T tables. You got to be a little bit careful with that because a T table is actually something in statistics. And what we do now is we just pick values. So let's pick a value for x. What would be really, really easy to plug in? Like a 0 or something? Yeah, a 0. Zeros are great to plug in because, zeros kill people. So let's just start with the first value here, 0. We plug in 0 for x, and then what we do is we see what y has to be if x is 0. So let's see, we have y is equal to 2 times x plus 1, and x was 0. So if I plug that in, the 2 goes away, that whole term does, and I just get a 1. So y is equal to 1 here, right? That's kind of convenient. So that's a first point, and then we need to find a second point, right? We need another point to plug in. Any point, I'm going to pick -2, right? A lot of the time people pick -1, -3, whatever. We're going to plug in -2 and see what happens. So y is equal to 2 times -2 plus 1. So that makes it -4 plus 1, and that makes it -3. So that means for -2, I get -3 as a value. Now, 2 points is enough. That is more than enough to, well, it's not more than enough. It's exactly enough to graph a line. You really want a third point just to make sure, right? It's not the law, but it certainly helps. So usually what I do is whatever I picked for a negative value, I'll pick a positive value to go with it. So just pick the positive of it. There's no law about what you have to plug in. You just want to make sure that you can get distinct points. Okay, so let's go ahead and plug in y is 2, or x is 2. So y is equal to 2 times 2 plus 1. So that's 4 plus 1, which is 5 this time. Okay, so now we have 3 points. And let's, just so we're clear here, these 3 points, this point right here represents the point 0, 1. This point right here is the point -2, -3. And this point here is the point 2, 5. And so I have 3 points to put on my grid. So I'm going to erase this work here. You can always rewind it and find it if you need to. Let's get this off of here, and I'm going to draw a little graph. So let's see what we got here. So this is going to take a little doing. How about, let's try, oh, this works so much better with the pen on. Let's try this one more time. Oh, that's not too bad. I've done worse. Okay, so let's go ahead and plug these things in. So first we want the point 0, 1. So x is 0. This is my x-axis, and this is my y-axis. So x is 0 is here, and then y is 1 pops up to here. I'm going to go ahead and put the rest of these tick marks in here. I know this is riveting watching me put these tick marks in. Pay close attention. There's a technique. Okay, there's no technique. That was a joke. Okay, so the first point, 0, 1, would be right here. And let's see, -2, -3. So x is -2, y is -3. So that drops me down here. And then the point 2, 5 is up here. Notice they look like they're on a straight line, right? If one of your points ended up down here or something, that's clearly not on a straight line, and so that would mean that you have a problem. But we don't have a problem here. These guys line up just beautifully. Let's see if I can draw this okay. There we go. Right? They fall in a straight line. Another interesting little tidbit here. The point, and this is just a little bit of vocabulary. You'll hear this pop up. The point where the line, your solutions, the point where your line crosses the y-axis is called the y-intercept. Right? The point where it crosses the x-axis, oh, that's a terrible drawing. Let's do this again. Let's try it from this side. Right? Where it crosses the x-axis is called the x-intercept. So that's vocabulary that we're going to be using as we go through. In fact, once we start learning techniques, both of the techniques that we're going to learn involve finding an intercept first. And I want to point out that the y-intercept, you notice we found the y-intercept right here, and x was 0, right? Because that's the equation of the y-axis is when x is 0. So anytime x is 0, you're going to be able to generate a y-intercept. It's actually a really, really handy thing to know. Okay, so there we have our line. Let's go ahead and take a look at another example. There it is. All right. So next example, let's say we have working pen. Okay, let's try this again now. Let's say we have y is equal to 2/3 x minus 2. Okay, so you notice the fractions here. Now this is one of those things in the last case, because we didn't have any fractions to deal with, we could pick anything willy-nilly and it would be fine. However, we do have fractions this time. So we probably want to start by picking a 0, right? Because zeros are nice, they kill people. So we'll start with that for our first point. So if I make x 0, y is equal to 2/3 of 0 minus 2. Again, that's just 0, so I don't have to worry about it. So y is -2. You see how convenient zeros are to plug in, right? That should always be something that you check. Even if we're not graphing lines, just if anything that we're graphing, plug in 0 for x and see what you get for y. It actually is a very important thing. Okay, and then let's say I pick 2 to plug in for x. So for the next point, so let's see here, y is equal to 2/3 times 2 minus 2. Well, let's see here, so that's 4/3 times, oh no, that's 2 times 2/3 is 4/3, sorry, I don't know why I wrote that the parentheses back in. Minus 2, so we're going to need a common denominator. So this is 4/3 minus 6/3, and 4 minus 6, so that ends up being -2/3. That's not a nice thing to graph, right? We don't want to have to graph fractions. In fact, most of the time when you have fractions, it makes your graph bad because it's hard to find it on exactly where it is on the number line. So we want to avoid fractions if we can. So here's a good way to avoid fractions. So this point will work, but we're not gonna graph it right now. So this is kind of a, I don't know if I want to. I'll just put kind of a not an easily usable point. We'll check back later. We'll see that the point actually is a solution, but it's not a very nice point to plug in. So how could we pick a number that will guarantee that I won't have this fraction, particularly this fraction, when I'm done? And so I'm picking values of x, so that means I'm going to be multiplying whatever x is by 2/3. So we want to be thinking about what can I make x so it'll cancel that denominator out. And it turns out that it's a common denominator thing, but if you just pick x to be positive and negative of the denominator, you'll cancel it out every time. So since this denominator is a 3, I'm going to plug in 3 and I'm going to plug in -3 because I know those will cancel that out. So let's go ahead and take a look. I'm going to redo a computation here. So let's try y equals 3. Y equals 2/3 of 3 minus 2. Well, that's a 3 over 1, so those cancel, and I get 2 minus 2, which is 0. So when I plug in 3, I get a 0. And then when I plug in -3, so y is equal to 2/3 of -3 minus 2. The same thing happens. That cancels, but that's a -1 now. 2 times -1 is -2. So it's -2 minus 2, which is -4. So these are the points. We'll plot these 2 points, and we'll plot this point up here, and then we'll use this as a check. So sometimes you have to fumble around with these a little bit before you find the thing that's going to work well for you. If you don't like the point you're getting, try a different one. There's nothing wrong with trying something else. In fact, you usually end up learning stuff from it. Excuse me. So let's go ahead and graph this thing now. So let me get this off of here. Again, you can always rewind to go look at it. And yeah, so let's see what we can do. That is not how I intended this. Let's try this again. Okay. Okay, it's not working for some reason. There we go. Okay. All right, so let's go ahead and graph our stuff. So this is our x-axis, this is our y-axis. Looks like nothing goes beyond -4, so that means I have to make sure everybody goes at least 4 in whatever direction they are. So that's 4, 5, 1, 2, 3, 4, 5. Okay. So let's see. So we start with the point 0, -2. So 0, x is 0, y is -2, goes right there. The point 3, x is 3, y is 0, would be right there. And the point -3, -4 would be right there, right? Because you can kind of map it out this way. And you notice they all fall in a straight line, which is fantastic. That means we probably did things correctly. And then we can go through and kind of take a look at this guy and see if that still makes sense. So we plugged in a 2 and got -2/3. So let's see, if I plug in 2 right there, that looks like it's probably around -2/3 if we draw that in. So that's actually, that was a good point. It was just very difficult to graph, right? You could definitely use it. If you're using a computer to graph stuff, then, you can put in all the fractions you want. Okay, so that's our second example. Notice again, It was just about finding points. It's just plugging in x values and finding the y values that go with them. So once you have those ordered pairs, you can just graph them. The other thing I want to point out is you notice here we have our y-intercept at -2. X is 0 at the y-intercept. Again, x is 0 at the y-intercept. But we also have an x, oh, excuse me. That's the y-intercept, yeah. We also have an x-intercept here, and if I look at it, it's the point 3, 0. And you notice x is 3, but y is 0 this time. So when I found an x-intercept, y was 0. These are all things to notice because we're going to be using them later on in future lectures. Okay, so let's look at the next example. All right, let's get back to that. And let's go ahead and change forms this time and look at 2x plus 3y equals 6. Now, this is still a linear equation. This is one that's in standard form. Right? Whenever you have the x's and y's on one side and just a number on the other side, that's the standard form. Okay, it's the same business. You pick a value for x or for y, and honestly, you could pick a value for y in the other ones too, but it's just more convenient to pick x since it already says y equals. Here, since x and y are on the same side, it actually works out pretty well to pick either an x or a y. And I know what I like to do. I like to start out by plugging in a 0. So if I plug in 0 for x, let's see what happens. Let's see what y value I get with it. So if I make x 0, this gives me 2 times 0 plus 3y is equal to 6. That dies, and so I just have 3y as 6, and I can divide by 3, and I get y as 2. Not so bad. Now, so we have a first point. Now we need a second point. And I know what I like to do is plug in 0 for the other variable if I can, right? It's already set up here on the same side. And you saw how easy it was when I plugged in 0 for x. So why not plug in 0 for y, right? Be adventurous. Try something new. Okay, so if I plug in 0 for y, this gives me 2x plus 3 times 0 is equal to 6. And again, 3 times 0 just dies. It's a 0, right? This is why zeros are nice, because they kill people. Multiplicative assassins. Okay, so now all we have is 2x equals 6. And if I divide by 2, I get x is equal to 3. And so I have my other point, right? So now I have 2 points. I just need to find one more just to make sure that we're good from here on. And so I'm just going to pick values. Let's see, what can we pick here? Let's see. Most of the time when it's in this form, it's actually fairly difficult to pick just because of the fact that, what do you call it? You know that you're probably going to generate a fraction when you divide by one of those coefficients. So let's think about this. So I'm going to pick something for x. I want my last step, if I pick something for x, is going to be dividing by 3 with the y. So that means I want to try to pick something that is going to be divisible by 3. So maybe I want to try x is 6. If I try x is 6, right, and I plug that in, since that's a multiple of 3, I might be okay. So let's find out. I'm just trying things. Never know. It may or may not work. So let's see. If x is 6, this is 2 times 6 plus 3y is equal to 6. So that's 12 now. It doesn't cancel out. And then if I subtract 12 from both sides, I get 3y is equal to -6. And then dividing by 3, I get y is equal to -2. So that was a lot of work, but we have our point, right? And it was because I picked a multiple, since I was plugging in for x, I picked a multiple of whatever the coefficient of y was. I had already plugged in a 3 once before. I already have that one there. So if I plug it in again, I'm going to get the same point. So I picked the next multiple of 3, which was 6. Just try it out, see what happens. The worst thing that's going to happen to you is you're going to pick something that's going to generate a fraction, so you have to pick something else. That's pretty much the worst thing that can happen here. Okay, so we have 3 points. Let's go ahead and graph them. See what it looks like. Okay, so let's see here. Let's see. Make sure I have everything on the proper way. So we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 5, 6. Something like that. It's a good sketch anyhow. And let's go ahead and graph. So I need the point 0, 2, right? That's 0, 2. So that's right there. That's my y-intercept. And then I have the point 3, 0, which is right here, which actually turns out to be my x-intercept, right? Which is enough to graph. So I'm going to go ahead and just graph it, and then we'll see if this last point matches, right? We'll go ahead and draw it in. Let's see. Even makes that sound. Okay. So we have this here. Now let's see if the point 6, negative 2 makes sense. So this is 3, 4, 5, 6, negative 2. Let's see. Yeah, it looks like it's pretty close. If it's not right on our line, it's just because we didn't, or I say we, like you had a hand in this. I didn't draw a straight enough line. So, nonetheless, we have this one graphed now. Now, you may go through and find different points for this. If you have different points, you should still get the same line, because no matter which points you find, they're all going to be points on the line that's defined by that equation. So it doesn't matter which points you find, as long as they're on the line, you'll get the same solution. You'll have the same line as a solution when you're done. Okay, so let's go ahead and clear this one off. Okay, so here's 2 equations, and these are for you to go ahead and graph these. Right? So go ahead and pause your video here, do your best to graph them, and then go ahead and push play to see the solution. Okay, so let's go ahead and take a look here. We'll do these one at a time. I'll leave them both up here for the moment. And this first one, go ahead and make our table here. Let's see, we got our x, y, and I need to pick some stuff, so I'm definitely starting with a 0 first. And I can see from this, here's one of the nice things about plugging in zeros. If you are in the slope-intercept form, this form right here, this entire term dies when you plug in a 0, and all you're left with is this every single time. So this number here, if you plug in 0 for x, the y value is just the last number. You can actually jump to it real easy. Now, I need to pick a value to plug in for x. I notice that my denominator here is 4. So I'm going to plug in a 4 for x, and then just for good measure, I'm going to plug in a negative 4 and see what happens on that side too. So if I plug in 4, then y is equal to negative 3 over 4 times 4 plus 2. The 4's cancel. I end up with negative 3 plus 2, which is negative 1. Okay, now if I plug in negative 4, y is equal to negative 3 over 4 times negative 4 plus 2. Again, the 4's cancel, but this time it leaves a negative 1. So 3 times negative 1 is 2, or is 3. Ugh, 2. Where did I get that from? Oh, probably from the next number. So I have 3 plus 2, which is 5. Okay, now just in the interest of space, I'm going to erase some of this computation. You can always rewind it and look at it again if you need to. But I want to graph this thing. Okay. So we start out, we have 0, 2, which is my y-intercept. And then we have, let's see here, 1, 2, 3, 4, negative 1. So that point should be over here. And then we plugged in negative 4. We want to see if 5 makes, let's see, 2, 3, 4, 5. And then 1, 2, 3, 4. Okay. So if we go negative 4, 5, that puts us up here. And that looks like we have a straight line here. Pretty close. If we have an error, it's due to my drawing ability. Okay. Right, so that's what the first one should look like. Let's go ahead and take a look at the next one here. There we go. So let's start with the t-table. Let's do the same thing here. And again, it's in standard form. The first thing I'm going to do is plug in zeros. Right? It's just a lot easier that way. So I plug in zeros, and it looks like probably whatever's going to happen here, if I plug stuff in for x, I'm going to be dividing by 4 at the end. So maybe if I just plug in 4, we'll see what happens. So I'm going to plug in 4 for x for this last part, just because when picking the x, it's a good idea to use the coefficient of y. That's all. So let's see what we get. If x is 0, then this guy goes away, right? And that leaves me with negative 4y equals 12. And if we divide by negative 4, then y is negative 3. So I have the point 0, negative 3. Now here I'm plugging in 0 for y. So that means that this term will go away, which means that I'm left with 6x is equal to 12. And if I divide by 6, I get x is 2. So I have my first 2 points here. I have the point 0, negative 3, and the point 2, 0. So let's see if my guess of plugging in a 4 worked out okay. So if I plug in 4 for x, I get 6 times 4 minus 4y is equal to 12. And so that's 24 minus 4y is 12. Subtracting 24 gives me negative 4y is equal to negative 12. And if I divide by negative 4, I get y is equal to 3. So I get a positive 3 out of that. So that worked out pretty well. So I have no fractions here. So let's go ahead and get rid of this. And we'll see what we can do with the graphing part of this. Doesn't look like we're going to have to count too far on our axes. So that works out pretty good. I'm going to scooch over to this side. There we go. All right, so let's sketch this in. So we have 0, negative 3. So we have to go at least, the highest number here is 4. So we can go 4 in every direction. Okay, so 0, negative 3 is our first point. So that's there. And then 2, 0, which is right there. And then 4, 3, which is up there. And those look, in fact, the term for I didn't mean to do that. The term for points that fall on the same line is collinear. And these 3 points appear to be collinear, so I'm going to connect the dot. Whoa. You know what? I'm sure that point was actually supposed to be right here. We'll just go with it. Right? So this is what your 2 lines should look like. You should have one that goes down to the right here, crossing, crossing the y-axis at 2. And then over here, you should have a line that crosses the y-axis at 2, the x-axis at negative 3, and moves up to the right. Right? So as long as you match, you're good. Even if you use different points here, you don't have to necessarily use the same points unless you're told to use particular types of points. Okay, good. Now, we have one more thing to look at, and that's the case where you have things that they look like this. Either x equals a or y equals b. A and b are numbers in this case. So it's something like x equals, I don't know, 2, y equals -3. Right? These are separate equations. These are not the same equation. These would not be the same problem at all. So let's take a look at these one at a time. So I'm going to go ahead and sequester these off a little bit. We'll look at graphing x equals 2. Okay, so if we want to use a table for this, that's fine. Really what this thing is saying, though, is that no matter what you do with y, x is going to be 2. That's it. That's what it's saying. So if you pick a number for y, pick 0 for y, x is 2. Pick 1 for y, x is 2. Pick -3 for y, x is 2. And so all this is saying is that no matter what you do with y, x is 2. Right? So you can pick a y value and then make x 2. What's interesting about that is that's pretty much what we were doing over here. Let me hide. Just get rid of this. There we go. This line here represents all the x equals, right? Because remember, that's exactly how we went about finding, our x coordinate. This line, if I put it here on 3, this represents all the places the x value can be 3. If I scoot it over, it's all the places the x values can be 2. If I scoot it over again, those are all the places that the x value is 1. Right? So anytime you have an x equals, it's a vertical line. And you can actually see that over here too. If even with these points, if you just plot them, right? So here's x is 2. So let's see, 2, 0. It's right there. There we go. 2, 1. Okay, 1's there, so that puts it right on top. 2, -3. So if -3 is down here, that puts it down here. And if you notice, you connect the dots, and you have a vertical line. Right? And so anytime you have x equals, this is a vertical line. Through a. Right? Whatever a is, whatever number that is, in this case it's 2, you draw a vertical line through that number. Here's the danger. Because of the fact that these aren't overly complicated, it's really easy to forget them, right? Because you don't spend a lot of time thinking about it because you already understand it. So make sure that you're not forgetting these, right? It's one of those things where once you get it, it seems to go really fast and you kind of just overlook it, and so you don't study it. But it's really one of the more common things to miss because of that. Okay, now, so just so we're clear on this, if I had changed this to, x equals -1, then I would come over here to -1, and I would draw a vertical line there, right? I don't even really have to plot any points. If you know what the line looks like, you should be able to draw it. Now, something similar happens with the y equals b, right? So let's go ahead and we'll cut that off for the moment. And let's see, I'm going to have to take a little journey to another place on the screen. We'll do that. So let's look at this y equals -3. Okay, so just like with the x equals, let me go ahead and, come on. There. Will you knock that off? Sorry, my screen, it doesn't like this thing on there. Okay, I think that's what it is. Let's try this. There we go. I want to show all hidden. All right, I finally figured out the technology. Okay, so let's hide that and let's hide that. All right, so this line here, this one that's moving up and down, this represents every equation that has a y equals in it. If it's y equals a number, what it means is that it's everywhere that y equals that number. So here, right, if I put it right on 2, this is the equation of y equals 2. This is everywhere on the coordinate plane where y is equal to 2. If I move it down to here, y equals 0, that's the x-axis. So the equation of the x-axis is y equals 0. Down here, here's -3, so that would be the equation of y equals -3. Right? So it's one of those things where everything that says y equals a number looks like the same line. It's just a matter of where you draw it. Okay, so let's go ahead and see if we can graph this thing. Let me go ahead and scoot this over. I'll shoot up to the top corner again. If you were to work this out making a table, it's the same reasoning as was over here with the x's. The only difference is instead of x being frozen in place, y is frozen in place. So what it's saying is no matter what I pick for x, y is -3. Right? So if I pick 0 for x, y is -3. If I pick 4 for x, y is -3. If I pick -2 for x, y is -3. And so if I graph this thing, I end up with a horizontal line. Well, let's do this first. So right, so y -3 is right here as far as that goes. So the first point, 0, -3 is right there. If I go out to 4, -3, it's right there. And -2, -3 would be right here. And so you can see it's a horizontal line. It's parallel with the x-axis. Okay, so anything that starts with x equals a number, right? There's no y in it. If it's x equals a number, it's a vertical line. Looks like this guy over here. If it's y equals a number, then it looks like one of these. Right? So you can actually, excuse me, there's actually a number of ways to come about the answer. The easiest way is just to remember it. But if you forget, because again, these are easy to forget for whatever reason, you can always rebuild it this way, right? If you know what it means, that coordinate is frozen as a single number. If I see y equals -3, that means the y coordinate can never be anything other than -3. If it's x equals 2, the x coordinate can never be anything other than 2. And so building the table will actually create your vertical or horizontal line, even if you don't remember exactly what to do with it. All right. Okay, so that concludes today's exciting adventure. There, I got it right this time. All right, folks. I will see you in the next lecture, and until then, keep your pencils and your wits sharp.